Have you ever wished you could go back and fix that embarrassing moment from high school? Or maybe jump forward to see what the world looks like in 100 years? Time travel has fascinated humans for centuries, appearing in countless movies, books, and TV shows. But here's the million-dollar question. Is time travel actually possible, or is it just science fiction? The answer might surprise you. According to modern physics, time travel isn't just possible, it's happening right now, and you're doing it. But before you get too excited, let me explain what scientists mean by time travel, because it's probably not what you're thinking. First, let's talk about time travel to the future, which is surprisingly straightforward. Einstein's theory of relativity shows us that time isn't fixed like we once thought. Instead, time is relative and can actually slow down or speed up depending on how fast you're moving or how strong the gravity around you is. Here's a mind-blowing fact. Astronauts on the International Space Station are actually time traveling to the future every single day. Because they're moving at incredibly high speeds around Earth, time moves slightly slower for them compared to us down here. When they return to Earth after months in space, they've aged just a tiny bit less than the rest of us. We're talking microseconds, but it's real, measurable time travel to the future. This effect becomes even more dramatic the faster you go. If you could travel at 90% the speed of light for what feels like 1 year to you, when you return to Earth, you'd find that over 2 years have passed here. Travel at 99% the speed of light, and that 1 year for you equals 7 years on Earth. It's like a cosmic time machine that only goes forward. Gravity also affects time in fascinating ways. The stronger the gravitational field, the slower time moves. This means if you spent time near a massive object like a black hole, time would crawl compared to someone far away from it. But what about traveling to the past? This is where things get really complicated and controversial among scientists. Some solutions to Einstein's equations do suggest that backward time travel might be theoretically possible, but they require some pretty exotic conditions. One theoretical method involves something called a wormhole. Imagine space-time as a sheet of paper, and a wormhole is like folding that paper and poking a hole through both layers, creating a shortcut through space and time. If such things exist, and if we could somehow create or control them, they might allow travel to the past. But here's the catch. We've never found a wormhole, and creating one would require materials and energy that we can't even imagine producing. Another concept is called a closed time-like curve, which sounds complicated but basically means following a path through space-time that loops back to an earlier time. Some scientists have proposed ways this might work, involving things like rotating cylinders of incredibly dense matter or cosmic strings. Again, these are purely theoretical and would require technology far beyond anything we have. Now, here, where things get really weird. If backward time travel were possible, it creates some serious logical problems called paradoxes. The most famous is the grandfather paradox. What if you traveled back in time and accidentally prevented your grandparents from meeting? If they never had children, your parents would never be born, which means you'd never be born, which means you couldn't have traveled back in time in the first place. Your head spinning yet? Some scientists propose solutions to these paradoxes. One idea is the many worlds interpretation, which suggests that traveling to the past would actually create a new timeline or alternate universe, so you wouldn't be changing your own past, but creating a different version of it. Another theory suggests that the universe somehow prevents paradoxes from occurring. Maybe every time you try to change the past, something stops you, or events conspire to maintain the original timeline. Stephen Hawking, the famous physicist, proposed something called the chronology protection conjecture, which basically states that the laws of physics somehow prevent backward time travel from being possible. He once said that the best evidence against time travel is that we haven't been visited by hordes of tourists from the future. But here's something interesting to consider. Some aspects of quantum mechanics seem to suggest that particles can influence their own past states. In certain quantum experiments, it appears as though measuring a particle in the present can affect what happened to it in the past. This doesn't mean we can send messages to the past, but it does suggest that our understanding of time and causality is still incomplete. So, what's the bottom line? Time travel to the future is not only possible but proven. It's just that the effects are usually too small to notice in everyday life. As for traveling to the past, the jury's still out. While it's not completely ruled out by physics, it would require technologies and conditions that are currently beyond our wildest dreams. The reality is that time travel, as depicted in movies where people casually hop between different eras, is almost certainly impossible. But the fact that serious scientists continue to study these questions shows us just how much we still don't understand about the nature of time itself. What's truly amazing is that every time we learn more about time and space, the universe reveals itself to be far stranger and more wonderful than we ever imagined. Whether or not we'll ever build a time machine, the journey of discovering these cosmic mysteries is an adventure worth taking. So the next time someone asks you if time travel is possible, you can tell them, we're all time travelers, moving forward through time at the rate of 1 second per second. And who knows, maybe someday we'll figure out how to change that rate or even reverse direction. Until then, we'll just have to be content with the